Hello everyone. We have a question which says that coplanar forces of magnitude 20 Newton, P Newton, 3P Newton and 4P Newton act at a point. So basically, what is a coplanar force? Coplanar forces are basically those forces which are acting at one point. If you just look at the diagram, P Newton, 3P Newton, 4P Newton and 20 Newton, they all are acting at this particular point. Therefore, all these four forces are called coplanar forces. According to the question, they all act at a point. Definitely, this is a point in the direction shown in the diagram. The system is in equilibrium. Find P and theta. So basically, we have to find this P, which is a force, and this angle theta. The condition that they have given to us is an equilibrium condition, and we know that if it is an equilibrium condition, then the horizontal opposite forces are equal as well as the vertical opposite forces are equal. But before that, we should understand the horizontal and the vertical component. Most of the student I have seen that they have a misconception that the horizontal component is always a cos component. No, it is not like that. The angle, whatever is given to us, the side next to that angle is always a cos component of that particular force, and the opposite side is always a sine component. For example, if we have this angle given in the question, that means the side next to it would be a cos component of this particular force, and the opposite side would be a sine component of that particular force. Because the condition that they have given us is an equilibrium condition, so basically we have to split up into horizontal and vertical component, and it is an equilibrium. That means the opposite forces are equal. So I have mentioned the horizontal and the vertical forces for all these four forces. If you just look at this 20 Newton force with a particular angle theta, so 20 cos theta is a horizontal direction of this, and 20 sine theta pointing downward. For this particular P Newton with a 30-degree, the horizontal would be P cos 30 and this vertical would be P sine 30. For this 3P with an angle of 30-degree, that would be 3P cos theta, cos 30-degree the horizontal force for this one, and 3P sine 30-degree the vertical. As we can see, this 90-degree, that means it is a purely vertical force, so no horizontal component for this particular 4P. So splitting up the horizontal and vertical forces, so first of all let us look at the horizontal force. And horizontal, we can see over here we have 20 cos theta, and over here we have 3P cos 30 and P cos 30-degree. These two forces are pointing in this direction and 20 cos theta on the other. That means the sum of these two would be equal to 20 cos theta. We have done the same. 3P cos 30-degree plus P cos 30-degree equal to, because it is an equilibrium, equal to 20 cos theta, and definitely it is over here. And then after that, simply by simplifying it, 3P cos 30 plus P cos 30, because both are in P cos 30-degree, it would be 4P cos 30-degree is equal to 20 cos theta, and from here simply divide this 4 over here. So 20 divided by 4 would be 5, and we have P cos 30-degree, and cos 30 is root 3 upon 2, or you can also write it in decimal as well, and that with a variable P would be equal to 5 cos theta, and over here, and this is an equation one. By rearranging, P is equal to multiplying this 2 by 5 as 10, dividing by root 3 and cos theta. So this is equation 1 from the horizontal component. Similarly, we would equate the vertical component as well. As in the diagram we can see, the vertical component, we have 3P sine 30 pointing upward and 4P pointing upward. So the sum of these two, 3P sine 30 plus 4P, would be equal to, because it is an equilibrium, and it would be equal to P sine 30 pointing downward and 20 sine theta pointing downward, as we can see over here, P sine 30-degree and 20 sine theta. By simplifying it, 3p sine 30 and then placing this p sine 30 on the other side, both are in p sine 30 degree. So 3p minus p is 2p sine 30 degree plus 4p over here is equal to 20 sine theta. We know the value of sine 30 degrees 1 upon 2, and by cancelling this 2 and 2 we are left with p from here plus 4p. So p plus 4p would be 5p equal to 20 sine theta, and then dividing this 5 below 20, so 20 divided by 5 would be 4, so p is equals to 4 sine theta, and that is equation 2. Our target is to find the value of p and theta. So we have two equations in the form of p is equals to 10 upon root 3 cos theta and p is equals to 4 sine theta. So we could easily equate both of them because both are in the form of p, as you can see over here. So we can write that 4 sine theta is equal to 10 upon root 3 cos theta because both are in the form of p, and we have done the same. Now sine theta over here, just divide this cos theta over here and just divide this 4 below over here and multiply it by root 3. So 10 upon 4 root 3 from here, and cos theta and sine upon cos would be 10. The value of 10 upon 4 root 3 would be 1.443, taking the tan inverse of this, and finally we have found the angle which was asked in the question. Now we can place this value of theta in any of the two equations, whether the equation 1 or whether the equation 2, in order to get the value of p. For example, if we take equation 2, which is p is equals to 4 sine theta, placing the value of theta over here and then simplifying it from the calculator, we have the value of p as 3.29 Newton. So definitely we have found the two values which were asked in the question.